Ngalakin Khadijan Nyunga Boja.
Hello. Can everyone online hear me? Hello. Great, thank you. Just give me a few minutes, we'll start in a couple of minutes. I even got my slide set, it's beautiful. That'll save me from messing around. All right, folks. Probably best if we made a start.
Recording in progress.
Wow, okay. That's loud. That's good to know. Okay, thanks everyone. Today we're fortunate to have Conrad Drake come and give us a guest lecture on safety, which is an essential aspect of all design. Conrad has been supporting this unit for many years now, and he's an engineer with a lot of experience, presently contracted to Woodside. So I asked you to welcome him, and we'll get going.
Thank you. Okay, thank you everybody. I'm trying to cover a couple of related topics today, and I'm going to quickly go through what we're going to cover, hopefully what you're going to take away from this at the end and know what, as I said, hopefully have some learnings. You can say, yes, I know that. It's a very short time to cover a lot of material, so I'm just going to touch at the top and hopefully give you some practical ways to deal with these things, particularly if you come out of here and you go into a small shop where they may not be quite as organised as some bigger companies. Happy to take questions on the fly. I will give you a bit of a break in the middle and get some feedback. To get a little exercise for everybody, just to stop everybody having to listen to me drone on for a whole 45 minutes. Love feedback at the end, and we'll take questions at the end, and happy to hang around for a while at the end. So what are we going to cover? I'm going to talk mostly about risks and hazards because these are the frameworks in which we tend to deal with safety and design. Talk about some of the ways to deal with that, matrices, and also understand some options for management, and also a little bit about the legal framework. I can talk for 45 minutes on the legal framework and still only touch the top if you really want. So I'm just going to touch that very briefly. Let's see if I can get the next one. Framework. If you've ever come to some of my lectures, you'll see this slide. Traditionally, we used to do theory at uni and that was it. Now these days, we're getting a little bit more organised, and that's been a 10, 20-year project at the universities. What we're talking about today is this thing called practice. How do we do stuff out in the workplace? It's really an area of a thing we call systems engineering, which is about how do you actually make a big project with lots of people work. And there are a couple of legal aspects to this as well. So we'll come back to that. What the industry normally does. So there's these things called hazards and risks. Hazards are defined in law and regulation to be things that are potential source of harm to people, the environment, and again, depending on which law it is, it's written slightly differently. But fundamentally, hazards is about doing bad things to people and the environment. They're things that might happen. Risks are generally things that are bad that might happen. There's an inverse risk. If things might go better, we might call that an opportunity. And as an engineer, one of your roles is to spot not just the risks, but also the opportunities. We tend to measure these things by giving them a cost. Mostly because that gives you things to balance against, but there's still some rules that we have to play in. But even things like the NTSB, the North American Transport Safety Board, has a price on a life. So if you're looking at doing some trade-off of should we add this piece of the kit to every aircraft in North America, it's going to cost this much, and we expect to save this many lives. Is it worthwhile? Sounds a bit brutal, but somehow you've got to make those judgments, and that's how they tend to do it. Hazards. As I said, people and the environment. It's not just the user, it's the constructors, the maintainers, anybody who might touch whatever it is you're doing, and also the surrounding populations and surrounding environments. I've got a few examples there. I'm not going into in great detail, but it's all sorts of things. I mean, there's a hazard in this room, and the guy, that row there, you guys, look up. Right, can you spot the hazard? Right. There's a couple of big, heavy bits of metal sitting above your heads there, right? So that's a hazard, okay? And I might come back to that one. It's one of my favourites. Normally it's above my head, but it's above you guys' heads today, so I'm a bit happier. Risks, on the other hand, are all the other things that could go wrong, like the projector doesn't work. That's not a hazard, that's just a risk. And there's lots of types of risk, and some of the ones I want to talk about, who here knows about Juukan Gorge? Anybody? Little company called Rio? Thank you. What did they do? Yeah. That sort of affects probably would I be correct in saying the last thing here, the loss of social license? What do we think of Rio at the moment? Do you think it's improved their perception in public, or maybe not improved it? Yeah. So we have this. So this idea of a social license, even though technically, it may not have done anything yet to the company, it's certainly affected their ability to go and say, we want to do this. We're great people, and it's going to make it much harder for them to do anything. Thank you for that, by the way. So, examples of risks. I'm not going to read through those. Hopefully you can read through most of these. Bug 437 is a random number I pulled out of my hat, but everything else here is something that I've seen or been involved with. Unfortunately, I didn't do the engine mounts, but that has caused a number of recalls on aircraft 737s about 10 years ago. The one that happens, probably you've all experienced, your power supply fails. They are one of the number one places of failure in electronics for a number of reasons. Okay, what do we do about these risks and hazards? So the Australian standard, and I'm going to forget the number, I think it's 3160, we'll check at the end, I've got it in the references, was the world leading standard for dealing with risks and hazards, and in the way we treat them, we do them almost identically. First thing is, what are they? Then how likely are they? What could result? So that thing falling off the roof there, well, we're going to try and make it not very likely, but it could have some fairly bad results. Classification, how does it compare to the other risks in this room? So down there's a PowerPoint, and that's, there's risks inherent in PowerPoints. There's electricity in there. There's lots of trip hazards I can see in here. Fortunately, no cables running across the floor here. So there's lots of sorts of risks, and we like to compare them to other ones, and that'll come back to what can you do practically later on. And ultimately, what are we going to do about it? And I'll go into those in a bit more detail with some examples. What we tend to do is to have this idea of a risk or hazard matrix, and we tend to sort things by how likely they are to happen and how bad it is if they do happen. That's one from British Standard. Here's one that I've used in a project which looks more at money. So I'm going to hit the right mouse button there. Let's see if that goes back previous. Sorry, run. This was about harm. So this is for hazards. And so where I work at the moment, we sort by, is somebody likely to get injured? Is it going to cause disability? Is it going to cause a loss of a limb? Will it cause 1 fatality? Will it cause 20 fatalities? So anyone here know Woodside? Or know what Woodside does? Geez, that won't make commercial. Thank you. What business are they in? Oil and gas. What do we know about oil and gas in terms of hazards? It can blow up, right? So they have the opportunity to kill 20 or 30 or 40 people at a time. So this is a real issue for them. A bit like aircraft, if they fall out of the sky, lots of people tend to die. So we've got, in where I work, we've got a lot more grains to this, but the idea is the same. And the important bit, so the colour coding here, is at a certain point you have to do something. And you as an organisation have to decide to do things, or when you're going to make decisions. So there's some things here at this company. They basically said, if we're going to lose, we've got 50% chance of losing the whole value of the contract, we're not going to do this, whatever that might be. Or it's getting sued by that chap's family when the thing falls on his head. On the other hand, there's stuff that's like, okay, we can live with that. And in between, there's grey areas, and you have to decide as an organisation, and that could be you and your group doing a lab or doing a report about, well, how likely are we to get this thing done on time? You need to have those conversations and decide where you're going to make trip points. And typically, there's a point at which you have to go up a layer or two and get somebody who's responsible legally in the company to sign off. So that's very typical. There's also, depending on where you are, what business, what company, what country, what legislation, the words do vary a bit. But the ideas are always the same. I like this slide. Who knows who NASA is? Come on. Yeah, okay, what do they do? Space. Tricky stuff. Rocket science. Yeah? So this is out of one of their standards which talks about looking at different options. So their engineering team is looking at a mission, and they've got 3 options, A, B and C, that might have different degrees of delivery versus different chances of total mission cost. B is probably the proven one, and it may be that this is something they've done before. So they know exactly how much it's cost and they know how effective it's going to be, which is not very effective. A is probably the poster child because it looks like it's going to be really effective, but it's going to cost a lot of money, and clearly there's some uncertainty in this graph. Well, that's what this graph is telling me. Option C, on the other hand, looks like it might be in the middle, cost and effectiveness, unless something goes wrong, in which case it's going to cost an awful lot of money and nothing's going to happen. So this is just another way of talking about a type of cost trade-off. And this is, when you get into quite complex systems, you sometimes need to put slides like this together to try and communicate your story, what your team's analysis has said. So this is a really good slide that probably sums up 6 months of work for 20 or 30 people. I'm sure you guys will be putting slide packs together for your group works later on. So this is a really good piece of data, or rather presentation. Anyway, classification. We're looking at appropriate responses, deciding the priority because we can only do a certain number of things at a time. And one of those things is to decide to stop. Has anyone here done any work in the construction industry? Got any postgrads here? Yep. So you've done your construction industry white card? Okay. So theoretically, in your work, there's times when you're supposed to talk to your colleagues, am I correct, and say, this is an unsafe situation, right? Even though you're not the boss, right? So this is a response to setting up a way for people to say, we need to stop, and we need to stop now before somebody gets killed. Unfortunately, it's still in a dangerous environment. So, which brings me to the next point. Often we've got laws around that, and your correspondent up there has gone and done a particular course. I talked about a white card. You can't work in the construction industry without having a white card which says you've done certain safety training. There's a whole bunch of regulations and rules, and we'll come back to some of them. And the other thing that I like is while people don't normally like hearing bad news, when it comes to risks and hazards, the earlier you identify them, the earlier you tell people about them, the better chance that the organisation and management has a chance of doing something about it, and doing it in a way that doesn't cost a lot of money or really delay things. So this is bad news early when it comes to risks and hazards. And again, I'll talk about that a bit more. It's a thing called a top 10 list. So I'd rather, if you're working for me, come and tell me what the things you can think of early, because often it's somebody with a different viewpoint has come in and said, oh, that doesn't quite look right. So we've just had a little opportunity where we managed to we were designing a crane for something, and actually got a crane operator to come in and look at the 3D models. And they said, this is silly. We're going to create hazards here. All the engineers thought it was lovely, but when you sat down with the operator and they went through what they were doing and what they'd have to do regularly, it became very clear that we need to reorganise the location of some equipment to get them better views of what they're doing and better access and safer access to the stuff they have to lift off them. I'd love to tell you more, but I don't have permission to do that just yet. I'll try and get it for the next one. Okay. Having identified our risks, worked out what bad things could happen, and sort of sorted them into priorities, we now have to work out what we're going to do with these risks. And this is really your only options. You can say, in the case of something that's a low risk, you say, okay, it could happen, it's not going to hurt anyone, and it's a really odd, not much chance of it happening, so we'll just live with it. Transferring, anyone here own a car? Right, so you pay your registration? Right. Can you remember the 3 topics, or there's 3 lines on there? Right, okay. One is called third-party insurance, right? That's an example of transferring a risk. So if you have an accident, you don't have to fund somebody else's hospital bill. So he's transferring the risk to somebody else. So insurance is a classic form of transfer. Sometimes you can do it contractually. So if you're a builder, typically you want to transfer the risk of the ground being not what you've been told back to the owner. It's usually the owner has to have that risk. Mitigate. I'm going to pick on our guys in the middle. You'd like to mitigate that risk, wouldn't you? Right. So we want to do something to make sure that those projectors stay where they're supposed to stay. And you may actually do things like make sure there's not a single point of failure. So there's only not just one screw holding it up. You might want to put 2 screws in, or you might want to have a separate chain as well as some bolts. So there's ideas of layers of protection and there's all sorts of other models to look at these, particularly where you've got fatal risk hazards, or as you say, 40 people might die. You don't want to have just one thing stopping it, bad things happening. Ultimately, the last thing there is that you can come back and inspect the risk. So, no, we won't have any civil engineers in the room. Last night on the television, we had a great show called something that was about great bridge disasters. And part of the problems with bridges is they get corrosion in them, and they corrodes the reinforcement steel, and eventually, if that fails, then the whole bridge falls down, which has never been anything good said about that. So one of the things you do is you constantly go back and inspect. But even on other things, it's a case of what's the probability? Has it changed? Has the impact changed? So you can decide to go back and look at a risk again, maybe in 6 months or 12 months. And last point here is, I've come back to money. Factored probability, cost of the risk is basically how likely is it times what's it going to cost me if it happens. So let's say, we think it's 50% likely to happen, and it's going to cost us $1 million, then it's $500,000 worth of risk there. And the idea of that number is then, if I can make that risk go away for $100,000 or whatever it is, $600 a quarter or a year, then that's probably money well spent. And so as an engineer, that's sort of what we're doing, is trying to say how much is it likely to cost, what's the probability, therefore we can spend that much money making it go away. Particularly once you start to run into intangible risks. As I said, Juukan Gorge, I don't want to try and put a number on that, but we know it's a bad thing just from this, it doesn't pass the pub test. It's a really bad look. So that's where so there are options in terms of dealing with these things. My friend up there will have seen this before. Have you seen this picture? Right. It's probably the single most important picture you'll see on this topic. And there's some lovely ones around a shark in a swimming pool. If you've got a shark in a swimming pool, the best thing you can do is take the shark out. That's elimination. And basically, as we get down this list, we get less and less effective. So PPE, bicycle helmets or steel cap boots or gloves or whatever it is the least effective way of dealing with things. It's even less effective than administrative controls. So don't swim in the pool, there's a shark in it. It's probably more effective than putting someone in chainmail and throwing them in. Engineering is in the middle. Putting guards around machinery is important, but it's much better to either remove it or use a process that isn't as inherently dangerous. So substitution, again, you can probably work out again when I talked about bad news early. You can't substitute stuff once you've bought it and put it in the field. You can only do that very early on. So you get big value early on in the piece. Likewise, engineering things out, eliminating them. Basically PPE is about the only thing you've got on the day other than saying, please don't swim in the pool, there's a shark there. And that sounds a bit flippant, but that's the driver. That's why we want to talk about this stuff really early. The footnote here. I think this has now been, depending on which state you're in, about 10 to 15 years. That total factored cost, if I say there's only 1,000,000 to 1 chance of it happening, but it's going to cost me $1 million, it's not worth me spending $1 on it. In fact, it's cost me more to think about it and write it down, which I do recommend, than to do it. The flip side is the case law and now the regulation now explicitly states that if you can spend a reasonable amount of money to make a hazard go away completely or reduce it, you should spend that money. Practically, what does that mean for us? So I did a construction site a couple of years ago, and they got lots of two-way radios. Every single one of those two-way radios that's in a building now has a lightning arrestor on the antennas. This is probably something that I wouldn't have done 20 years ago because cost value doesn't make any sense. But the fact that it's something relatively cheap that I can do to significantly reduce the risk of the operator of that radio means now I have to do it. I'm very happy to be able to go to my managers and say, we've got to do this because it's the right thing to do as well. So it works for me down here as well as up here. Yeah. So that's a bit of a change. So beware of that as you go into industry. That is the bar. You can't just say, well, it doesn't happen very often. It doesn't make sense economically. Okay. I'm going to stop talking for a while and give you about 120 seconds or so to have a think with some people who are sitting with you or just in your own mind. We've got this lovely company called the Smoked Sausage Company. It's a long-standing small goods brand. And basically what they do, they get meat, they do stuff to it in machines and hang it in smoking houses and put it in fridges. And they wrap it up and pack it in boxes, stick it in vans and distribute it. And, and obviously they've got a big warehouse out the back. So, 2-minute exercise. What could possibly go wrong for a company like this? I'm going to literally set a timer for about 60 seconds. Just have a think and talk amongst yourself. What could go wrong? What sort of hazards exist? What sort of risks to the business can you identify? I think that's it. Yeah, here we go. Risks and hazards. How might you classify them? What might you do about them? Literally, if you can just think of one, perhaps talk to the people next to you, and then we'll get to see how you go. Yeah, and some clues. Here we go. Time.
Okay.
Nice to meet you.
Oh, good.
Yes.
Yep.
Sorry, we should have checked. Is it you okay being filmed?
Yeah. Old habits. Yeah.
That won't get recorded. I think it's just
Yeah.
it's just that because Conrad's saying it helped me hear. Someone needs to see it.
I didn't realise PPE was the lowest on that food group.
Yeah. No.
And so I work with lawyers, and we do a lot of stuff on eliminating contracts and trying to replace them with graphics, visual contracts. And the biggest problem with lawyers is that they are completely risk averse.
Yeah.
And they actually don't know. So we have lots of risk assessment now in law. Actually, why have a clause in there if it's not ever occurring and the impact of it occurring is so low? And yet, they'll add it to a contract, make the contract 100-odd pages, and then no one reads the contract. So the effect of the contract is actually affected by all these minute clauses that actually don't mean anything. So,
Yeah, it's interesting.
Just muted that discussion.
Right. Okay, everyone, your 60 seconds is up. Can I get some ideas? Anyone? Up the left there, maybe up the back? What could possibly go wrong in making sausages and storing them and distributing them?
Well, the easy one is say someone could get their hands caught up in machinery.
Yeah, pretty ugly. Any others? Yep.
Food poisoning if food's not stored properly under
Yep.
refrigerated conditions.
And what sort of things could cause that?
Refrigerator malfunctions or contamination with other products.
Yep. So you can see there's trees that might end up with the same. There's all sorts of different things that could get the same result. Anywhere up over here?
Possibility for fire.
Yes. Yep. And what sort of thing? Go on, keep going, keep talking.
And the meat may get spoiled if the refrigerator
Yes.
is not working.
Yep. More refrigerator problems.
So in the smoking process, they might cause a fire in the factory.
Yes.
Or the trucks might have a delay or breakdown to the distribution end.
Yep. So gear gets there late. Any more? We've had fire, mangulation, refrigerator breakdowns. Anyone want to add with some more? Sorry? Yes, definitely. Yeah, another cause of potential. Yeah, price of beef going up. So that's a risk to the business. I guess. Yeah. Did I say? Yeah. Please.
Issues with transportation.
Yep.
So you keep issues with the beef when you're distributing it.
Mm-hmm. Yes. Yep.
Demand might go down, so there might not be a buyer.
Yeah. Yep. Okay. Anyone want to add one more? Please.
Consumers may not like the taste of the sausage.
Yep. Okay. Yes. Yes, which we've seen quite a lot of recently. Okay, so there's lots of good things there. I think, again, and practically in fact, every single one of them you could find examples of. Trade barriers right now, we've got issues with which markets we can put our stuff into. Transportation, there's a big challenge if you want to buy a sea container at the moment. There's some real challenges because they're a just-in-time product and the world's supply chain for shipping containers has got all tangled up. I worked with a chap, and one of the problems we had was in an environment like this, they wanted to put the product straight into a foam box and then put it in the freezer. And we ended up having to put thermometers in there and measure the temperature to convince the owner they actually needed to chill the sausages first before he put them in there. I picked this particular example because there was a company called Garibaldi Meats in South Australia. Somebody is probably old enough to remember. They had been in business for 120 years. They got some spoilt meat in there, or possibly from one of their workers, some salmonella in there. A 74-year-old gentleman got sick and died, and the company went out of business, 2 weeks later? That was it. They couldn't sell anything to anybody. So anyway, coming back to why we're talking about this, as the owner of the business, this is a key job that management structure has to deal with. They have to go through everything you do in the business. Where could you injure your operators? We got somebody talking about getting your hands caught in the sausage machine. You've also got to have people cleaning those sausage machines. And I know I've got a friend whose partner ended up on invalid pension because she was one of the people who cleaned them, was under a machine, hit her head, couldn't wear a helmet on there. It was badly designed equipment, right? So as engineers, we have to think about not just the operator, but also the installer, the maintainer, and decommissioning. Any questions on that before I sort of move on? Is that all resonating and sound reasonable? Okay. Okay. I'm going to talk a little bit about the law. Not a huge amount. But there's fundamentally two types of law. There's the stuff that politicians write and public servants write, which are called Acts of Parliament, and then you have regulations that are set up as a result of those acts, and some of those acts and regulations call up standards that must be complied with. On the other hand, you have a thing called common law, which is where a magistrate or a judge brings down a ruling that, if anyone's seen a show, there's this idea of precedent, which is last time this came to the court, this was the result. And if a magistrate or judge makes a particular ruling, that effectively creates a law, or creates how the law should be interpreted. And under that, there's a general idea of where that law came from. Was originally what's known as tort law, which was about injury. And that's injury either to yourself, your reputation, or your property. And that's the oldest kind of law, going back a very long period, where people would come in and say, I've been unjustly dealt with, he's taken my pigs, she's encroaching on my land, he's telling everybody I'm a nasty person when I'm not. And that was the early form of court law. So in some senses what we're dealing with is the oldest form of law. At the other end, we've got regulations that change almost daily. As an engineering manager covering 7 disciplines from civil construction through power, little power, telecommunications, fire, Wi-Fi, wireless. Literally, my engineers were coming to me every week with updated regulations around the world, around the country, because we operate in multiple states. So as an engineer, one of your jobs in your discipline of choice is to know what the law says about your industry or about your technology. And I'll come back to that a bit more. There's also very specific pieces of acts. So in particular, there's a general duty of care for designers. So if you're making anything that's going to be used by somebody in this state, you're covered by this law, whether you know it or not. I'm not going to go through in great details. Again, there's references in the back. But the main thing is, again, this word, as far as practicable, comes in to make stuff safe and reasonable. What I was just saying, it changes daily. On the other hand, sometimes we've been talking about this particular model legislation for OH&S, where Western Australia is about 20 years behind the rest of the country, and we've been talking about changing it for about 20 years. It still hasn't. The key takeaway is the bottom line. When we're doing design, we're looking at what might happen, and we have to make a guess. The judge, on the other hand, has hindsight and can look forensically at all the stages that caused the end result that ended up with one of us being in court defending our actions. One of the best defences, and I think I talk about it later, but I'm going to say it now in case I forget, is to write down what you're thinking. So that should something bad happen, like the projector falling down there, the various people along that chain have records to say, we thought about this, we didn't think it was very likely, but we did these things. Now, it may be that you're wrong, but at least it demonstrates that you thought about it and that you weren't negligent. Likewise, if you can demonstrate that, yes, I did this job in accordance with best practice at the time, you've got a reasonable defence. It's not for certain. There was an attempt in the late 80s to sue somebody for designing a building to a code that didn't exist for 40 years after the building was designed, but generally, I think that was one extreme of the pendulum. I think we're back in a bit more in the middle. So there's this issue of foreseeable, reasonably, what a reasonable person would do, but we are supposed to be experts, so we're a little bit of a higher bar. Oh, another long-winded piece of legislation. But in this case, they've asked for a written report. So, again, here is something that you must do. If you happen to be under this legislation, merely thinking about it and writing it down doesn't cut the mustard. You've actually got to give your client a written report. So again, you need to know what the regulations for your business or area are and technology area are. When you come out of here and go into a workplace, or even in here within things like your laboratories, and I know there's some pretty good labs in here, there should already be responsible people there who know what you need to know. I'm going to come back to that in detail, but when you go into a workplace, it's a reasonable question to say, what are our, what does our business need, technology, and from a industry perspective in terms of regulation. And people should know that. So if I go in the physics lab over there and they've got a high voltage experiment or they're playing with liquid oxygen, there should be somebody over there who knows what the rules are. And I'm sure there's paperwork around it as well. But okay, practical management. First step is do your safety review. Again, you should already have people in your workplace, your industry, your laboratory who know what the rules are, but it's still important for you as an engineer within your team or project or process to do that review. What do we call it in construction? When we start doing the job and we sit down as a team and we start writing down what we're going to do and what the issues are. JHA, job hazard analysis, right? SWMS, safe work method statement. How are we going to do this work and how are we going to make sure it's safe? So most industries have something like that. I'm just like you, I've got a white card, so I should know this stuff off the top of my head. Get expert help. So if you're coming into the smoked sausage factory and they want you to put in a new piece of machinery or a new system, maybe something like a microwave that they haven't used before, they're not going to have the knowledge. You're bringing in a new system. So you're probably going to have to go outside and find a consultant in the area that's a specialist. Published results I've talked about before. Again, what I call the top 10. Whatever job you're doing, and it could be just your university lab, right? Maybe you're setting up something that you've got to demonstrate in week 13. One of your risks is that on week 12 somebody sits on it and breaks it, or the cleaners come in and knock it over, right? Probability? Yeah, pretty low. But one of the things you could do as a project team is look at what are the things that could happen that stop us getting a good mark, right? And particularly what's going to, well, one of the things is we don't do the demo. What could stop us getting to the demo level? So such an, maybe our key, we were expecting one person to do the presentation. Well, what if they get sick or they get hit by a bus on the day of the demo? What are you going to do? Now that sounds a little bit contrived, but that's the sort of thinking you need to have, particularly as the stakes get a bit higher. Does anyone want me to go through any of these line items? Basically, this is the sort of thing you need to know about all your risks and hazards. Cool. Nope? All right. Yeah. And the last thing is, if it's a slightly longer project, check the changes. Because again, if we've got a price associated with a risk and that risk isn't going to happen anymore, suddenly you've got free money and you might be able to return that or do something else that you want to do with that money.
With the costs factors, if you're trying to find a cost for risk that someone hasn't done,
yep.
Is that do you base it on does the law state what the cost should be for like a human life, for example, or something else, or do you go by what other people have done in the past?
Yeah, I think sometimes there are frameworks, but generally it is trying to work out what the cost of something is. It may be blatantly obvious, or it may be something your insurers typically will have a good idea. So I have $20 million worth of public liability insurance for a little business we have at home. Why I picked $20 million? That's what the insurers and the people we leased the property from said was about the right number. So that's, again, it's usually you're going to have to go and talk to experts because it's, for me, it's not my core business. I'm sure there are risk engineers that is their core business, and you will discover in your business that there are people, particularly with large organisations, who eat, live and breathe this sort of stuff. Thank you for the question. So yeah, all companies should have a defined HSE structure because every company has that duty to provide a safe workplace, right? What's the food delivery company in New South Wales that is currently going through all this fun because they didn't bother to train anybody on the road rules of all these delivery riders. And they're trying to say, well, they're not actually our employees, and everyone is saying that doesn't pass the pub desk, right? Likewise, they should have a risk and management process. Our smoked sausage company should have at every board meeting the list of top 10 risks for the company. And the management team should be working them, and there should be people responsible for them. A big company is usually going to have nice processes. It's going to have common definitions, tools. I worked for Raytheon. They had a great process where I could say my little $20 million project here has $4 million worth of risk, and the CEO could see that if he decided, and it was a he at the time, decided to go down and see why that little organisation had so much risk on such a tiny project. I'm not going to talk more about that. That sort of brings me to the end. I think I've taken out a slide to try and bring me in on time for a change, which I have done. I've sort of alluded to it again. If you're in a small organisation and you don't have these frameworks, that doesn't mean you get to ignore it, particularly around safety. You are responsible, and all I can suggest, and this feedback from comments the other day, is write down your risks and what you think are the problems for your work, and give that to your line manager every week or every month in just, this is what I did this week, this is what I'm doing next week, and by the way, here are our risks, and here we go, here's our performance, right? Again, if you've got a project that you're doing, you also probably want to do a little bit of risk management. Not a lot, but given that, it could be the difference between a pass or a fail or a excellent, what's the top mark now called, an A or a B, right? You probably have a little bit of skin in the game, and so you might want to think about that. That's all I'm going to say. Here's a bunch of references. The only one I'm going to talk about at the bottom is the model code of practice. If your industry has them, that is the minimum bar. We talked about safe working method statements. Practically everything in construction has a model example of this is how you write one. You don't have to follow them, but if you don't, you need to explain to the judge why you didn't. And that's all I'm going to say. Thank you very much for your time.
Questions, anyone?
No question? Got to be one question. Oh, all right, cool. Oh, yes.
Yeah, just, so you said you were working with Woodside currently,
Yes.
correct? This is more like this. It's more just like a curiosity question. Who's regarded as the best and the worst in like WA mining or oil and gas when it comes to managing risks?
Generally, oil and gas is ahead, simply because, as your colleague pointed out here before, there's a much bigger chance of things going horribly wrong. And when they do go horribly wrong, they tend to be very public and very hard to hide. Trying to remember the name of the gas plant in Victoria that blew up about 1996. When you blow up a gas plant within the side of Melbourne, people tend to notice. So they are much more serious about it. The mining companies are coming up, and again, the big ones, the big issue is the bigger you are, the more likelihood of your time, what they refer to as time of exposure, is longer. So I've just come off a construction project that had 20 million hours without a lost time injury. What that means is we worked 20 million hours. So if something had a 1 in a million chance of happening, it was probably going to happen 20 times on that job. So the bigger you are, the better you have to be. Whereas if and it's the same thing. If you're, doing something once, you might not get too excited about it. But if you're doing it every single day or 8 hours a day, a week long, you're going to have to be a bit more serious because your exposure time goes up. So a bit of a loaded answer to a loaded question, but I hope it's useful. Cool. Any more? Yeah. Opportunities are a little bit harder, but often it's, particularly for technical things, it's turn it around the other way. So, okay, I'm going to allow, maybe if I'm doing I think I'm going to need 3 prototypes to get from here to here, or if you're doing software, you might say, I think I'm going to need 6 2-week cycles to get the software to minimum viable product. Or there's a whole step here that I might be able to take out of the process. So those opportunity frameworks are things like, particularly in process, if you can remove manual handling processes, that's how you do things today. There's an opportunity there to, well, okay, if we get some machinery to do this, or instead of unpacking it, we make a special frame and everything's packed in the frame and we get a forklift to pick it up. Right, that's an opportunity to take out risk. And if you can do it while saving, and save money at the same time, or reduce error rate, defect rate is the big one. A line I love is, if I'm writing doing something once, I'll do it by hand. If I'm doing it 10 times, I probably want to write some code just to get the defect rate down. So that's the sort of trade-off, and they're all, as I said, they're sort of anti-risks in that you're assuming something's going to go this way, but there's an opportunity for something better to happen. And you can almost manage them in the same thing. It's a bit of a conversation with you, with your peers and your reporting structure. And it varies a little bit organisation to organisation about how they treat risk financially and who gets to hold the budget. So do I get the money from the risks on my project, or does corporate hang on to it and I have to go begging to get the money? And so there's some questions around that sort of thing as well. Okay. Any more? Hazards, did I talk enough about hazard? Is everyone happy? That's the slide I've taken out. So is everyone happy they know what a risk is? Yep.
Just a question. At your company, how is it exactly that risks are identified and reported?
Yep. Sorry, you missed your first word.
Oh, identified.
Yep. Okay. So some industries have requirements that you will do things. So in construction, one of the last things you do before doing work is, as a team, you're meant to stop, look at the workplace and say, does it look like what we wrote in our safe work method statement? Every time you come back from lunch, has it started rain? Has something changed? Has the wind picked up? Has the rain started? Has somebody else started working next to us and made our work unsafe? So there's that immediate thing. The other is quite strategic, which is looking at markets. How is the market likely to move? So at Woodside, there's a whole floor of people who just look at what the oil price might do over the next decade or two, and what various people might do and where they might move. Everywhere in between, you've then got typically gates in your project where you will formally sit down and review them. And as I said, general good practice is that you need to be talking about them with your team and your management structure at least once a month. So I'm in the middle of, because I'm coming back onto a project, we're restarting it. We're going back through every single risk and making sure it still makes sense 9 months later. So does that answer your question? Good. Okay, so we talked about risks, hazards. Can somebody tell me what a hazard is? Everyone happy? Difference? Treatment? Process? Hierarchy of controls? Yeah, any questions on any of those things? Otherwise, I'm going to presume that's sort of mostly sunk in. Yes? Okay. Please.
Someone asked last week,
Yep.
so I'll paraphrase, is a standard law.
Right. Very good question. And I did actually give the answer, but it's a tricky one. The answer is only when that standard is called out by an act or a regulation. So I can't mess with that PowerPoint there because the law says there's these regulations, and one of those regulations says you need to be a licensed electrician to do that work. And by the way, all that cabling has to be done to AS 3000, which is a nice big standard you can buy. Likewise, while I can design that and I can design the, there are standards called out in the law for designing, Wi-Fi, right? I got in trouble, and on the Impex gas plant, we bought a Wi-Fi unit in our spares supply chain. Somehow a grey market one slipped in, 900 megs Wi-Fi. It got reset because the power went down. About 2 days later, I got a phone call from ACMA saying, please turn that off. Do not turn it on ever again. It's because it was interrupting Optus's, because it was running on the wrong spectrum. And that is law. That's about a $300,000 fine bit of law in my case. So we turned it off very quickly. So yes, and it really, the tricky bit again is, does that apply to me in this context? So depending on which, where you're talking council bylaw, state law, or national law are three different things, and they have different coverages, and it gets very messy very quickly. So that's a very good question, and as engineers you need to know the answers for your speciality or your